Hello and welcome along to Doz's Television Workshop. It's part 3 of the Sony 9-306 Extravaganza. As you can see, we've got some pictures on the set, but things aren't quite right. Let's take a look and see what's happening. Okay, so my video rack's currently got a fault on it, as I said in the last episode, but I've managed to sort of do a quick repair so we can get a test card. And it's a bit flickery now. I'm not sure that's the fault in the video rack because I've run some other video into it now. It does actually look okay. Let's just see if we can remove the camera flicker. You're going to be obstinate. Oh. Anyway, let's zoom in, see if we can persuade it. Come on. There we go. Right. Okay. So you can see that the picture isn't quite filling the screen. We're a bit low, top and bottom, and this is a 4x3 source, so I'm not expecting any black bars. And also you'll notice this white triangle here, one, it should be almost off screen, if not completely off screen. Two, it should be in the middle, which is between the 0 and the N on the Sony label down here, which is sort of here. And we're not, we're off to the right. So on 405 line, the line holds off as well. That is interesting. You can see now I'm not again worried about the flicker too much. That's more than likely the video rack or this wobbling at the top, because we're using equalization pulses and that was never in the standard. It does make some sets hook, and in fact it makes a 990 hook, so it wouldn't be surprising. But as you can see, pictures, this C here should be in the center and it's not. It's off by about the same amount again. Also, we got too much height this time. So we got not enough on 625 and too much on 405, and we've got the same offset. So reading from the service sheet, it says here, where is it? Yes, operation on 625 and 405. There is no difference between the frame stage. The frame stage remains identical. The line stage, of course, is switched because the horizontal frequency of a 625 line picture is 15.625 kilohertz, and on 405 it is 10.125, which is why we can hear that whistle. In fact, no, I can't really hear 625 line whistle anymore. A lot of people can, but I'm getting too old now. 405 is deafening, but yeah. So the line stage switches, but the frame stage remains the same. So why are we getting this difference in height? You going to look up? No, we just need to adjust that 405 preset slightly. But it's not quite right. And yeah, so there's no difference in the height in the frame circuit at all. Therefore, the difference in height, I think, is being caused by the line stage generating a different amount of EHT. That doesn't solve our centering problem because it should always be centered. Now, there are various things we need to check. Now, there are a set of capacitors that are switched when we switch standards in the line stage, and they're switched. So the line stage tuning changes, and also not only the line stage tuning, but its frequency of operation. Now, being as the fault is the same, the offset fault is the same on 625 and 405. Therefore, it's not down to one of those components that's being switched. So let's have a look and see which components we think may be the cause. Okay, so this is the diagram. I've recycled it from last time because I've got a bit of a confession. Now, we had two capacitors. Sorry, we changed 3 capacitors last time. One we can't find, C504, which supplies the grid with video information from the video driver up here. And what I thought was C811, and it's not C811 at all. It's C816. I was a little bit concerned about C811 because that's tuning the line output stage here, which could give rise to some problems, but it's not. It's C806, and all that does is sort of decouple the focus voltage. So there's a confession there, and it's because the two diagrams I have differ slightly. As you can see, That's one diagram, and that's the other. Although the capacitor numbers are the same, the board layout photographs are different. So anyway, let's just go back to this. Those diagrams are more or less of the same thing. I'm just going to use this diagram because it's a little bit clearer to read. So the sync separator is down here. And these are the line preset adjustments. S14 is used to switch between 405 line hold and 625 line hold, and there's a global line hold here. Okay, and this is a part of AGC circuit. Anyway, pulses of line rate come up here, and this is the horizontal oscillator. It's a blocking oscillator formed by TR801 here and T801, which is a transformer. So what I was thinking is maybe that our oscillator free running is slightly off ramp. So what we've got to look at, I think, is C801. C802 we know is innocent because the fault exists. Again, there's a standard switch here, 625 405, and again S12. So we know 804 and C802 are innocent. C803 on the other hand and C801 possibly not so. Also, this core here is L801, that's an inductor, and it's variable. We can try adjusting that. I don't think that's going to cure the problem because I think our pulse width is in the wrong place. Now, in the circuit here, 806 doesn't have a value. It's a suit-in test. So there is some instructions for setting this. I'm just going to switch to the other diagram for a second. Now, there's our blocking transformer and our blocking transistor again. Here's its feedback. See C806, it's got a triangle by it, doesn't specify a value. And that's because it needs tweaking. So waveform 20 is correct. So I think one of the first things we can do is check that waveform 20 over here looks something like that on the oscilloscope. Now the numbers in brackets here refer to 405 line. These are 625 values. So let's take a look at that waveform and find out a little more on what's going on. Okay, so bit unfortunate camera angle this time because I've lost the camera over there because we've now got a camera on the oscilloscope probably, and I'm running out of cameras. Right, so the scope's hooked up to the correct test point to have a look at waveform 20. Sets off, the scope is roughly set up somewhere near, so let's apply some power and see what happens on the scope. I'm just going to make sure we've got the relevant picture. We're on 625 lines, by the way. Okay, so that's running. Let's just set the trigger a little bit and get the time base somewhere near. Okay, oops, too far. Right, that looks something like waveform 20, so we just want to go in there and measure the width of this bottom section here. Which according to our diagram should be, where are we, waveform 20, between 12.5 and 13.5 microseconds. Yes, so it's 12 microseconds. Where does 12.5 take us to? Delta. Oh, it's as near as damn it is to swearing. Okay, so let's just go back into measure there and see what our maximum voltage is. So we've got 26.8 volts and we should have 38 volts. Okay, so that's a little bit different. Now it also says that this piece here should be 7.5 volts, so let's go back into cursors. Type voltage and set that one down there. Yeah, 7.2 volts, so we're near enough, but that does worry me that the peak's not quite right. Okay, let's switch to 405 lines. Okay, there we go. Obviously the line constant's changed, so let's turn that back down a shade. And we've still got around 7 volts there. What's our peak? See, 29 volts, and actually on 405 lines that should be 44. And we should have 13 to 14 microseconds on the pulse width. So yeah, so that's pretty much spot on. This voltage worries me. I wonder if we're just not seeing the peaks. Let's just switch trigger off again. Move the whole waveform down. And zoom in a bit. Let's switch the cursors off. Zoom in a little bit on this peak. It just isn't there, is it? The most important part I'd have thought of this waveform is the peak, so it triggers the line oscillator correctly. Okay, so that's investigated that, and I'm fairly sure it's okay. Let's move on, see what else we can discover. Okay, so we've checked our waveform 20, and I think it's reasonable. Now, I'd like to check waveform 21 and work our way through. However, physically this is rather difficult to get to, as is the output from the horizontal drive transformer. So our waveform's coming down here, it's being used to drive the primary of the horizontal drive, and then the output is actually isolated. So that's then driving our horizontal output transistor. So if we look at waveform 23, and that's okay, which is over here, waveform 23, which is like that. Quite big peaks here, 150, 180 volts, relevant spacing. Spacing's not going to change, I don't think. We should be alright there. And then we go into the flaky world of line tuning, the harmonic tuning, which is this lot here. Again, we know these two here are innocent, 812 and 813. Let me just switch diagrams again. 812, yeah, 812 on this diagram seems to be fixed. Look, and 813 is switched. See, 811 is still original, despite the fact that's the one we got wrong. It's 816 we changed. 810, and yeah, that's about all. That's just coupling focus to ground, isn't it? So 819, you see, that could be important. That goes to chassis via these two resistors. It's developing a potential. Okay, let's not worry about that too much. But these, I'm worried about. Also, we've got C817, which is the S correction capacitor, which couples the line from the output through the line coils and back. That might be a good place to start, actually. C817. Okay, let's look at some of these caps in the set and see what we can decide. Okay, so we're going to check the waveform on the collector of the line output transistor. Don't, whatever you do, attempt this in a colour set, because you'll blow your scope from here into the middle of next week, because there are thousands of volts of pulses on here. This set being considerably smaller, we're not expecting that. So set's running. And what does that tell us? 170 volts. We're on 405 line, 170 volts. Our diagram says 180, so that's somewhere near. What about our pulse width? Voltage, time, oh, that's near enough. We are looking for, I think it was 15 microseconds. Let me just call the waveform page up on the computer again. 405, we've got 15 microseconds. We've got 15.6, that's near enough. Okay, we move to 625 line. Okay, we want a peak there of 150 volts. We've got 146, okay, somewhere near. And we've got a pulse width of 12.8 and the book says 12. So it's a matter of interpretation there really, isn't it? We're pretty close to the mark. Okay, so that all looks all right. So we're into the misty realms of line tuning. Okay, so we're into the misty worlds of line tuning now, and I've just been looking. Do you remember those red NCC caps I changed? Well, this one here, let me just attempt to zoom in again. Okay, look at that. Down the side there, oops, it's got a split in it. Now that is C811. Yeah. So I'm going to take that out and measure it and see what it measures like. Because all I didn't mention that in the second part of the video, but all these red things we had last time that I took out. Oh, there's one. Look, it actually broke up. As I took it out with a pair of pliers, but all of these measured bad. They were all over the place in value, so not good. And that's for the peak. And I did check that. I doubted myself and actually checked this against a known good capacitor, and it's spot on. So let's cast doubt upon these red capacitors and go from there. Right. Okay, so let's take the line time-based panel, sorry, the time-based panel out again. Screwdriver is beginning to lose its magnetism. That's got it. Okay. Come to me, my old friend. Oh yeah, let's take that feed from the power supply off. Just gives us a little more wiggle room. That's better. Yep, that's super. Right, it's right down the bottom left-hand corner here. In amongst some other bits and pieces stuck to the back of the board, so yes, this is going to be a challenge to get at. There's the loop. Ooh. Bit of desoldering braid on there. Appears to be one leg. And that appears to be the other. Okay. So, according to the label on him, he's a 0.01 plus 0.005. So is that what's going on with this sort of soldered on thing at the top? Right, let's see what we've got. (103 picofarads). Well, that's not right. Let's test again. 14 nanofarads. Yeah, 0.0, so that's 0.015, isn't it? 14, 15 nanofarads. Yeah, he's innocent. Okay, let's put him back in and move on to the next one. Ow! Something's just bit. We're all off. There's no mains lead. So something's stored a healthy charge in there somewhere. How unpleasant. Right, let's just gently get at that without grounding ourselves this time. Just shows the unpleasantries of this. I'm glad I didn't swear on camera. That was very good at. Okay. Right. And what I discharged. Right, these go up to... No, it's nothing to do with it. Okay, what else need to be looking at? Let's have a look at that one, which is C. That was C811, wasn't it? Ironically, the one we said we changed last time that we hadn't. What else we got? C10, C810. C810 is underneath the transistor. Oh, he's in very good nick. He's one of those green ones, and they don't tend to be guilty of anything. I have had them fail. Okay, so that capacitor proves innocent. 810 next to it is just the sort that doesn't really fail. If we get stuck, I'll come back to him. Next thing I want to change is, or check rather, is the scan correction capacitor, which is somewhere by the width control. So here, there's the width line, there's L803, which is our width control, and it's C817 there. And these are actually the line output coils here. So let's just have a look at that other diagram because it's that much clearer. Right, yeah, there's the width coil. So there's our standards switch there. C817, so in 405 line, that just goes straight out to the width control via there. And straight with B, C817, and then straight to ground. Now that's interesting. That means we've only got width control on one standard. I need to check that. Anyway, C817, it's in series with our line scan coils here from our line output transformer. So that's the circuit that way around. Let me just get that again. C405 line, width, ground. 625 line. Oh, we've actually shorted the width coil out, haven't we, that? So it will still be in circuit because it'll be in here. Not much though. Okay, 625 line, I expect that to do almost nothing. Right, so anyway, C817, which according to my information is 3.5 microfarads at 50 volts. So let's go and have a look at that. Okay, so the S correction capacitor, which is tucked down here on the side of the scan coils. So I'm going to need to disconnect the line scan coils at one side. Let's just try it. We might get lucky. I doubt it. It'll probably hideously confuse the meter if I attempt to do it in circuit. But hey, try anything once. Okay, so it's supposed to be 3.5 mic at 50 volts. And we've got nearly 270 microfarads. So you can't measure it that way. I knew that would be the case. Just me being lazy. So which is the line scan coils? It's that one there. So let me just disconnect it from there and from the output itself. So that's the output there. So that's isolated the capacitor and one half of the coils, which is neither here nor there. Analysing, what are we going to get? 1.560 microfarads. You see that? Let's hold it up for the camera. Can you see that? 1.56 microfarads. That's not enough. Now, you'll notice it's a big yellow thing. It's not an electrolytic because we're passing, obviously all the line scan current has got to pass through here. So, just notice the scan yoke is loose as well. That might be interesting. That might be why our picture's not so centered so much either as well. Right, so he's going to have to come out of there. The easiest way is to snip him out. You see, it could be leaky. There could be DC flowing in there, which will give us an offset. All right, let's snip him out. Let's see if I can get him to yield. And of course, I've got to find something to go in there. There's no point in me attempting to put an electrolytic in there. All right. Okay. I'm going to go and have a look in the box. There we go. Should probably see it better on this camera. Let's put a bit of light on the subject. But he's well down in value. Well down in value. Let's go and find something suitable to fit in there. Okay, I'm somewhat embarrassed by my lack of a 3.5 microfarad suitable capacitor. I have, however, put two 2.2s in parallel. Now this says plus minus 20%. So 10% will be obviously 0.3. 5, so 20% would be 0.6, so 3.5 plus 0.6 is 4.1 anyway. So we're on top tolerance-ish. These are MKT orange drop capacitors, so they're good for the job. So they've been sort of lashed up in there temporarily. So now let's put some power on. Right, we're in 625. Just switch the light out there so we get a better illumination from over here. Oh, okay. So sort of vertical hold out, we'd be better off, wouldn't we? Okay, so that's good. Picture's nearly in the middle. We may be able to square that up by altering that. Oh, in fact, we noticed earlier that the scan yoke was loose. What's the better? Ooh, steady. Where's that screwdriver for propping the chassis up? That's the one. Well, there's not that much movement in it. And even so, F, look, it's right smack in the middle. Can we see that on there? Yeah. So I reckon that's pretty near. What do we like on 405? Okay, we've got a height issue. Still got a height issue, and our width now is low. But you can see again, we're pretty much central in the screen. We're looking a lot better. So I'm betting now, if I adjust the width up on both standards, so 625, how is our width? Pretty much cock on. The height's a bit low maybe. Not enough width on 405, but remember when that switches over, our width control in 405 does quite a lot. So let's put the set on its side, and let's see now if we can't get the width looking something like. Okay, put that out of harm's way. I've also noticed now on 405 there's a lot less whistle going on. Okay, so have we got any width control? We have width control. And look at that, our height's coming in. Okay, let's just set the height a little bit on 405. No, we've only got one height control, so let's just get it somewhere near. Now that's too much still. See? Okay, we might want some centering going on, but again. Okay, what do we like on 625? We want a bit more height. And actually our linearity is not good on 625, is it? Remember, there is no difference. It's better. Okay, so that's acceptable. And that's pretty good. So there we go. It was down to our scan correction capacitor. Now I'm going to sort out this fizzy video arrangement. I know 625 line video coming out of the rack at the moment is bad. And I have to say on 405 we're looking pretty hot. It's looking pretty resolving. We get away with a bit more width, you know. Brings our height into a more acceptable standard as well. I have to sort out a 625 video, see how that's causing our roll or not. But there we go. Pretty good stuff. Right. Tell you one way to solve that actually is let's actually look at some TV pictures in the flesh. Right. That should be where are we? No or bad signal. That's because there's no antenna. Try that. Ooh. It's still very smeary, isn't it, the video? And we still got that terribly scratchy contrast control. That's not too bad. Let's move the 405 line converter over. Oh, that's 405 line test card F.
And he brought it home, and it's brilliant. She uses it as basically.
That is very interesting about the line whistle, though. Sounds very scratchy. Sounds like the speaker was sorting as well. But
I think the idea is rather than just a when down.
pretty good stuff. Right, we've made good progress. So much so, I think I'm going to clean the pots up and call that a day there for now. Right. Thanks for watching. Hello and welcome back to part 2 of what is a feature-length edition of Doz's New teeth, please. There are only 3 certain things in life. 4 certain things. Oh, for f***'s sake. Let's go again. That's crap hand. Let's do it again.